Find all zeros, both real and imaginary, of the following polynomial. F of x equals 2x to the fourth minus x cubed plus 7x squared minus 4x minus 4. Now, what we need to do first is get some initial rational zeros. And hopefully we're able to at least get 2, because if we can get 2, then we can factor those out using synthetic division and reduce this down to a quadratic, and then we can use other means to solve the remaining quadratic. To find initial zeros, we need to determine where this function is crossing the x-axis. And that we will determine through its graph. So 2x to the fourth power minus x cubed plus 7x squared minus 4x minus 4. And when I graph that, looks like I get 2 potential zeros here. Certainly there's one at positive 1. Go ahead and list that one and factor it out of the polynomial. So the coefficients 2, negative 1, 7, negative 4, and negative 4. Let's see, I'll bring the 2 down. 2 times 1 is 2. That adds up to 1. 1 times 1 is 1. 7 and 1 make 8. So this is 8. That adds up to 4. 1 times 4 is 4, and then the sum here is 0. So positive 1 is a 0. Now this other 0 right here, it isn't quite so clear. It looks like it might be negative 1/2. If you want to find out for sure, what you can do is you can hit second and calc, and then come down here to the 0 function. And what it wants are 3 input values. So it wants to know boundaries for that surround the 0. So like it's somewhere between -2 and 0 for sure. And then the initial guess I'll set at like -0.5. And then it calculates what that 0 is in that range. And it does come up with -0.5. So -1/2 is a 0. So then what I'll do is factor that out of the polynomial. But I've already taken 1 0 out of the polynomial, so I'm going to use this reduced set of coefficients. So bring the 2 down. 2 times -1/2 is -1. That adds up to 0. That's 0, and then that's 8. 8 times -1/2 is -4, and that adds up to 0. All right, so these make up the coefficients of a quadratic, which would look like 2x squared plus 0x plus 8, and the remaining zeros of this quadratic are going to be the remaining zeros of this polynomial. So I'll just set this equal to 0 and solve. So first thing I can do is divide both sides by 2. So x squared plus 8 equals, x squared plus 4, because I'm dividing each term by 2 there, equals 0. Then if I subtract 4 to the other side, I have x squared equals -4. And if I take the square root of both sides, it's x equals the plus or minus square root of -4, which can be written as 2i. So the remaining zeros here are 2i, or plus or minus 2i.